Okay, so today we're going to talk about polar coordinates. And graphing polar coordinates is really very similar to the way we would graph a vector if we were given its magnitude and direction. Polar coordinates are given in this form r comma theta, where r is the distance from the origin, and theta is the counterclockwise rotation from the horizontal, from the positive x-axis. And so what we're going to do is we're going to look at some of these different polar coordinates and sketch them. So if we look, for example, at the point that we're going to do here, A, it says that our R value is 7, so that's the distance from the origin to the point, and then our direction angle is pi over 6. So when you want to plot these, really it's best to look at them first, figuring out what is the angle that we're working with. So we would go ahead and look over here and say, oh, well, that's pi over 6. And then we would figure out, well, we need to show that we've moved 7 units from the origin. So when you look at each of these rings on our polar graph, you notice obviously it looks very different than our normal Cartesian grid. But each of those rings, as you move outward, is one more unit from the center, or from the origin. So for example, this right here, this circle, is 1 unit out from the origin. This one is 2, and so on and so on. And so what we're going to do is just count out 7 rings pointing at pi over 6. So 1, 2, 3, 4, 5, 6, 7. And that's point A. And it's as easy as that. Really the trick is just make sure you're paying attention to the angle first. Let's take a look at point B. We're going to do that one here. Now notice the angle this time is negative, meaning we're going to rotate clockwise. So I'm going to go to negative pi over 2, which would be down this way, which is the same thing as 3 pi over 2. So once we're oriented toward that angle, we're going to go 5 circles out. So 1, 2, 3, 4, 5. This is our 1. And we'll get rid of all that rest. We'll go ahead and call that point B. When we look at the next one, this is actually where looking at that angle first can be really helpful. So you notice our R value is negative. So that's going to imply something about the way that we move once we figure out the angle that we're at. So let's first orient towards pi over 3. Now if this was just 6 pi over 3, we would simply count out 6 circles and put our point here. But we don't want positive 6 and pi over 3. We want negative 6. So what we're going to do is move 6 units in the opposite direction. So we're going to kind of travel along this angle here. And we're going to go out 6 units. So 1, 2, 3, 4, 5, 6. This is our guy. And then let's make sure we label that one. That one is C. And then last, we're going to go ahead and do this point D, which is at negative 3 pi over 2. So that means we're working here with what's actually positive pi over 2. So our rotation is negative 3 pi over 2. And then we're going to go out 3 circles. So 1, 2, 3. So 3 units from the origin. And we'll go ahead and call that what it is, point D. So graphing these points is really very straightforward. Just orient yourself first towards what angle are we looking at, and then we'll figure out what our R value is. All right, so we want to think about 2 scenarios. What would the graph R equals 2 look like in the polar coordinate system? So if you notice, we only have an R value, no theta. So if we're trying to picture what that looks like, what this is saying is that all locations are 2 units from the origin. And so when we look at that, all we're going to do is think about, well, okay, we need every location that's 2 units from our origin. So as I look here, I can have all these points would give me an R value of 2. So for all the points where R equals 2, we've got this shape here. We've got a circle. Pretty straightforward. If R equals C, then C is just going to be the radius for that circle. So we'd have a circle with a radius of C. All right, so that's what happens if we have an R equals. Next question, what if we have a graph that says theta equals 2? So you notice now we don't have an R value. We're not being given a distance from the origin. We're just being given an angle. And so when you look at theta equals 2, we're saying all locations that rotate, get that right, that rotate 2 radians. Now I notice that this is radians because I see theta equals 2. There's no degree sign. There's no other indication of what the units are. So this is 2 radians. So when we're thinking about what a radian is, you might remember kind of how that breaks down around our circle, but they're about 57 degrees each radian. So 2 radians is going to be about 114 degrees. And if we're trying to look at all the places that are 114 degrees from the pole is basically the positive side of the x-axis, then what we're going to do is think about something somewhere around here. So we've got this, and you notice all of these points, no matter how far out the R value is, are about 2 radians from our positive x-axis. We can also imagine that this line would continue and would go down this way as well, right? So we'd either see that this is 2 radians, or from this side of the x-axis, that's 2 radians. And so you can see that that shape is a line. And so when we have just an angle given with no R value, we're looking at a line. All right.